In this video, we're going to look at graphing polar equations. So polar equations are usually written in terms of r and theta. And then to graph a polar equation, we're going to plug in values for theta to find the r values and plot the points, similarly to how we would have in the Cartesian or the rectangular plane with plotting x and y points. So your polar equations will look something like r equals 3 sine theta. A lot of times polar equations will involve trigonometric expressions. So let's look at some examples here. So this one we're going to start with is just r equals 5. So no matter what my theta value is, r is 5. So it's like a constant function. So easily enough to fill in the table here. All of my r values are 5 regardless of my theta value. So then I'm going to plot these points. I'm just going to mark my axis here. Then I'm going to start plotting my points. So this is the point, remember, it's r theta. So this is 5, 0. This is 5 pi over 12. This is 5 pi over 6, etc. So this first point, 5, 0, so I'm going to come out to 5 and rotate nothing. And then 5 pi over 12, so I'm going to come out to 5 and rotate pi over 12. Then we're going to come out to 5 and rotate pi over 6. Then we're going to come out to 5 and rotate pi over 4. And we're going to rotate pi over 3, so we're just going to keep going. So if I look at kind of connecting the dots here, what I'm ending up with then is just a circle with the center at the pole and has a radius of 5. So I have a circle, center at 0, 0, and radius is equal to 5. All right, so here's a second example. Here we have r equals 4 times the cosine of theta. So now as I change my theta values, my r values will change. So then I'm just going to take my calculator, I'm going to make sure that I'm in radian mode, and I'm going to find these values over here. Then again, I'm going to start plotting these points. So again, remember this first point is 4, 0. I'm going to plot the point 4, 0, and then this next point is going to be 3.9 and then pi over 12, so I'm going to come out just about to 4 and then rotate up one section, and then we're going to do 3.5 pi over 6, so halfway, and then I'm going to go 2 rotations, and then 2.8, and we're going to rotate pi over 4, so not quite all the way to 3, and I'm going to rotate to pi over 4, and then we're going to have the point 2. So this is the point 2, pi over 3. So I'm going to come out to 2, and I'm going to rotate to pi over 3. So I'm here. Then we have 1, 5 pi over 12, so we're going to be here. And then pi over 2, so this would be 0, pi over 2. So that's just going to be here. And then we're going to go -1, and we're going to rotate 7 pi over 12. So I'm going to come out to -1, and then I'm going to rotate 7 sections. 1, 2, 3, 4, 5, 6, 7. And then we're going to come out to -2, and then this would be 8 pi over 12. I'm going to come out to -2, and then we're going to rotate 8 sections. So 6, 7, 8. And then we're going to do -2.8, and we're going to rotate 3 pi over 4. So I'm going to come out almost to -3. And then I would be rotating 9 sections, so 6, 7, 8, 9. And then -3.5, and we're going to rotate 10 sections. And then -3.9. And then at -4, we're going to rotate pi, which is a half circle, so that's going to be bringing me back to here. So then those points would just keep repeating again. So again, I have a circle, it's just not centered at the origin now. So here again I have a circle. The center is going to be here. So my center is at 2, 0, and my radius is 2. Alright, so here I've got another one. This one's slightly different because it's theta equals 120 degrees. So now I have a constant theta value, but my r value can change. So it's a little bit different than the ones we looked at previously. So this is going to be theta is 120, and r can be anything. So we'll say 0, 120 degrees 1, 120 degrees 2, 120 degrees 3, 120 degrees 4, 120 degrees, let's go -1, 120 degrees, -2, 120 degrees, -3. And then I'm going to start plotting my points. So remember, this is 0, 120 degrees, and then this will be 1, 120 degrees, etc. So here is going to be 0, 120. Then I'm going to come out to 1, and I'm going to rotate 120 degrees. So remember, this is 90, and then these are each 15 degrees. So then this would be 105, and then this would be 120 right here. So then I'm going to come out to 2, and I'm going to rotate 120 degrees. And I'm going to come out to 3, and I'm going to rotate 120 degrees. And we're going to come out to 4 and rotate 120 degrees. Then I'm going to come to -1, and I'm going to rotate 120 degrees. So again, remember, this is 90, that'll be 105, and then this would be 120. And I'm going to come out to -2 and rotate 120 degrees, and -3 and rotate 120 degrees. So you can see what we're getting here is a line that's actually on that value of 120 degrees. So here we have a line through 0, 0. All right, one more example here, and this time we have r equals 4 secant theta. So remember, I can rewrite this 4 over cosine of theta. So again, the first thing I'm going to do is fill in my table. Okay, so once I have my points in my table, then I'm going to start plotting them. So remember, again, this is going to be 4, 0, 4.1, pi over 12, etc. So I'm going to come out and plot the point 4, 0, and then 4.1 pi over 12, so I'm about here, and then 4.6 pi over 6, so almost halfway, a little bit past halfway there. And then we're going to go 5.7, so not quite to 6, and I'm going to rotate pi over 4, so I'm about here. These I can't really plot on my grid that I have here just because my numbers are too big. Pi over 2 is undefined. These two, again, I can't really plot. So this one's going to be -5.7, and then I'm going to rotate 3 pi over 4. So here I am, -5.7, and then 3 pi over 4 would be 9 rotations, or 9 sections here. So remember, this is going to be 6, 7, 8, 9. And then we're going to do -4.6, and we're going to go 5 pi over 6, so that's going to be 10 sections. So 6, 7, 8, 9, 10. Then I've got the -4.1, and we're going to rotate 11. And then pi, or -4 pi. So here I'm at -4, and then pi. I'm going to rotate around, and I'm going to be back at this point here. So then again, my points would just start to repeat. So basically what I have here is a vertical line through the point 4, 0. Okay, you can use your calculator to graph in polar mode. So the first thing that you would want to do is press your mode, and you would want to go to polar. I recommend graphing in radian mode. It's a little bit quicker. The degree mode kind of slows your calculator down a little bit. Then you're going to put your equation in, and I would start always with a zoom 7, which is your zoom trig, and then change your window if you need to. So when you go to your window, you're going to see some different things. So you're going to have these theta values, and then you'll have your typical window values, your x-mins and your x-maxes, and your y-mins and your y-maxes. So we have to be careful with the theta min and the theta min and the theta max and the theta step. First of all, the theta step is going to determine how smooth your curve is, but also if you make theta step too small, then your curve is going to plot really slowly. So you kind of want to be careful with that. And then your theta min and your theta max, like sometimes you're going to have to change that to get an entire graph. So we'll look at a couple examples of that in just a second. All right, so let's go to the calculator, make sure we're in radian mode, make sure we're in polar mode. So we've got that, and then let's go back and take a look at these ones that we graphed by hand. So this first one was just r equals 5. So once we make sure we're in polar mode, if you press your y equals, you will see that your window looks different now. It used to be y1, y2, etc. Now it's r1, r2. So remember, when we were in parametric mode, it changed. So now also in polar mode, it's going to change. So here we're just going to graph r equals 5. So I'm just going to type in the 5. Again, I would start with a zoom 7. And then you can see your circle. You're a little off here because of your window. So once I do that, I'm going to do a zoom square. So when I zoom square, it kind of adjusts my X and Y axis so that the grid is equal. So now you can see you got this circle. Now I'm going to press my window for a second, and I want to just talk about this theta min and theta max. So right now you can see that you're going from 0 to 2 pi. So let's say we only went from 0 to pi. Then I'm only getting half of that circle. So remember, actually, when we plotted these points, we only got the first half of the circle, and then I just assumed that the pattern was going to continue to keep going there. So depending upon your graph, you may have to change your theta to make sure that you're getting all of the points that you need. So if we go back to our window and we change this back to 2 pi, you can see that we get the complete circle. So if we come over here and take a look at this one, we're going to do y equals 4 cosine of theta. Notice when I press my X button, now we're getting the theta because of our mode. Then again, I'm going to graph that, and then we can see the circle that we got there as well. Coming over to the next one, we had theta equals 120 degrees. So I can't graph that in my calculator because of the fact that in your calculator it's always r equals. So just like in your function mode, you can't graph an equation that's just x equals 7 or x equals -2. It has to be in y equal form. So with the polars, it has to be in r equal form, so we couldn't graph this one on the calculator. And then this last one we can graph. So remember, this was for secant theta, and we have to rewrite it as 4 divided by cosine theta. Again, I'm going to graph that, and I can see the vertical line that we got before.